So welcome back to another series of video, and we are on exam 2 from 2016 fall semester, and it's pretty much an exam on geometric of the molecules and organic chemistry, and now we are on question number 1. It says using Vesper theory, what is the molecular shape of the SO3 molecule? So pretty much the way we need to imply these kind of problems is that we have to draw the Lewis structure of the molecule first. So if we recall how we draw Lewis structures, we first count the total number of valence electrons we have. So the sulfur has 6, and each oxygen has 6, so it's going to be 6 times 3, and that equals to 24 electrons. And then we put down the one with the atom with the least electronegativity, or the most electropositive in the middle, and then we use the other ones to surround it, and we make a first first order just a simple connection between them first in order to form the molecule. I have no idea why my cursor is flying around, but it's just so that consumes total number of 6 electrons and leaves us with 18 electrons, and we just put down those dots around to the atoms with more electronegative atom first, and then let's take a look at the formal charges. So for the formal charge on each oxygen, it's going to be 6 minus 1, 2, 3, minus 1, 2, 3, 4, 5, 6, 7. So it's going to be a -1. So it's going to be a -1 on each. I hope I can just erase this carefully, but it might not work. Okay, so it's going to be a -1 on each atom of oxygen. And then sulfur initially has 6, and now it has 1, 2, and 3. So it's going to be 6 minus 3 equals a positive 3. So that's going to be a positive 3 on the sulfur. So apparently the formal chart distribution of this particular molecule doesn't look good. So we need to do some transactions in order to make it looks better, to make it look better. And actually, if you're doing Vesper theories, I suppose you don't have to do it, but just for a good behavior, for a standard, I don't know, a better manner of doing chemistry, let's just balance out the formal charge. So let's try to move this pairs of electron. I erased too much stuff. Let's try to move one pair of electron to the middle. So now the formal charge of this oxygen reduced to 0, and the formal charge of this sulfur reduced to +2, to a +2, and I guess we can just do the same thing for each one over here, and we remove one pairs of electron, and we make it a double bond. So this becomes 0, and this reduced to +1. Just careful. No, I erased it. The wrong color. Okay, so +1, and then we just finally we do another moving of the pairs of electron, and we get a nice looking molecule. I guess for the purpose of a better understanding, I just do both of them here. So I'll draw the initial one out first again, and then -1, -1. Where in the world does that square came from? Never mind. I think I accidentally selected something that I should not select, but that's okay. I have no idea why it's flying around. I guess it's just my touch screen is not synchronizing with my hands very well. I got some new equipment, and I'm still familiarizing how do I supposed to use them properly. And what the heck? Yeah, I learned the fancy word familiarize from the embedded control class. In the beginning I never know that's actually a word in English. So now they all reduced to 0, which is so this is a better Lewis structure. So now let's take a look at the geometry. So there are 3, as you can see, there are 3 preliminary things around the central atom. One is here, one is here, and one is here. So there are three groups. Three electron groups. Groups around the central atom. And so let's take a look. So numbers of electron group 3. So that's a trigonoplanar, which gives us the final answer. So this is a trigonoplanar atom, which gives us the answer C, or triangular planar in some sense. I guess it's just I think it's usually called trigonoplanar. Anyway, so the answer for the first question is C. And let's end here. And how do I switch it up?